All right. Thanks, everybody, for joining. Kind of the holdouts for some of the last sessions, so I really appreciate it. I also know that I'm competing with a keynote, so I'm very happy to have you here. My name is Justin Reock. I'm Deputy CTO at DX. DX is a productivity platform, an engineering intelligence platform, and we're able to look at a lot of insights around how various things, tools, technology, and things like that are impacting productivity within an organization. Right? And so this is where the data that you're about to see kind of from this study came from. We're able to pull insights from over 135,000 developers who are tracking AI utilization within the platform across 435 companies. We've looked at engineering org sizes from less than 50 engineers to over 10,000 engineers, and we'll break some of that data down in this study. And we're looking at regional, global companies, so headquarters in North America, LATAM, Europe, and Asia Pacific. So this is aggregated, anonymized data, and we use various reporting mechanisms to get this data into the system. Part of what DX is really good at is marrying qualitative signals from high-performing surveys, like 90% plus participation rate in these surveys, the types of surveys that are engineered to kind of look at developer experience as a systems problem, not a people problem. So we tend to get very honest responses. So as far as I know, this is probably the best data set that's kind of available right now in terms of how AI is truly impacting work across different cohorts and different kinds of companies. So that's what we'll share today. Now, there's a full report that dives deeper into some of this, which you are, of course, welcome to download. I'm going to share a few resources with you throughout the course of this presentation. And we have plenty of time. I think this is like an hour-long session. So I'll linger a little bit on some of these slides. This is the result of compiling a lot of this data. Myself and my CTO counterpart, Laura Taco, who some of you may know, she's very prolific in the developer experience space, worked together to put this guide and these various kind of figures together. So there's a lot in there. It's much more meaty than what we'll get into today. But we're going to cover some of the trends and some of the interesting details that came out in this report. All right, so first of all, let's talk a little bit about the current impact of AI, right? Where are we? Nobody knows. So, on the one hand, we've got Google telling us like, oh, our engineers are 10% more productive as a result of using AI. Now, of course, Google's already a highly productive company, focused a lot on developer productivity. They were pioneers in the study of developer experience. But on the other hand, we have this now, I would say, sort of infamous METR study, meter study, which had some flaws, don't get me wrong, that showed that developers who took part in that study were 19% less productive as a result of using AI. And this is Cursor. Now, there were 16 people in this study. Some of them had never even touched Cursor before, so that's flawed. But the one takeaway that I do think is really interesting from this study is that every engineer in that study qualitatively felt that they were more productive using AI. So I think that there's something about the tooling that's kind of fun. It kind of initiates a bit of a flow state, makes us feel like we're doing more work. But in this case, in this study, it didn't really turn out that way. So we have a lot of data. Let me get ahead of myself here. Dora also produces a lot of great reports. We work with Dora very closely. In fact, Nicole Forsgren, who invented the Dora metrics and wrote the book Accelerate, is one of our chief researchers. She and my CEO, Abhi Noda, just recently released a book called Frictionless, which talks about sort of a playbook for developer experience. So we work very, very closely with the Dora community. I have a lot of great friends there. They do a lot of great work. This data, though, tended to report impact on averages. So we're seeing these sort of modest but positively leaning gains from this study. 7.5% increase in documentation quality, 3.4% increase in code quality. So at least, not a huge leap, but at least not leaning in the wrong direction, right? 3.1% increase in overall code review speed. So again, these modest, but at least positively leaning metrics that we're looking at across broad averages. So then we thought, well, why don't we correlate that data and see what we found? And we found largely the same thing. So this was a sample of close to 20,000 developers. And this metric is called change confidence. It's a qualitative metric, and it's measured on a top box Likert score. So what is that? If you're not familiar with survey engineering, a Likert scale is when you say answer a question like always, very often, sometimes, And the top box scoring methodology means we want to see the percentage of people who answered always or very often, right? So the two like positive answers that you can put in that survey. So what you're seeing here is a percentage of developers that effectively answered a question saying that they feel like they can put stuff into production without breaking things. And what you're seeing here is AI users on the left and non-AI users on the right in the platform. And there's a 2.6% gain from using AI. Okay, yeah, great. Again, not huge, but at least positively leaning. We see the same thing with code maintainability, another quality metric. How much cognitive load do you feel like you have to expend to understand the code that's in front of you? And we found a 2.2% gain amongst AI users that they felt, that the code itself was maintainable, easy to read. Okay, cool. Then we looked at change failure rate. Who's familiar with DORA metrics and change failure rate and stuff like that? Good, a few of you. So change failure rate is kind of what it sounds like, the percentage of value-adding features that you release that then have to be reverted because they break something. And we saw a 0.11% reduction from using AI. Okay, the industry benchmark is 4%. So as sort of insignificant as that seems when you compare it to a 4% benchmark, it's a little bit more significant. So then we thought, well, this can't be right. Because we're talking to customers that are experiencing good things, and we're talking to customers that are experiencing bad things. So I thought, what if we ran the sample and we reported it company per company instead? Here's what we saw. Okay? Every bar represents a single company on this graph. You want to be on the top line here. This means some companies experiencing more than a 20% increase in change confidence, but also companies experiencing a 20% decrease. So when we look at the averages, when we filter by average, that's not telling us the story of what's really happening, right? We're actually living in quite volatile times. Now, there's a lot of factors that go into this. There's something that we're starting to refer to as agent X or agent experience, which is effectively that what's good for humans is also good for agents. And so companies that have already spent a lot of time like perfecting their automation and doing a lot of work on their SDLC and getting all the right code hygiene things, they tend to be obviously on the top line of this graph. The irony is that all of this investment in AI and agents and everything might finally get companies unified about caring about the things that we should have been doing for developers years ago. So we saw the same thing with code maintainability, same volatility here. We saw the same thing with change failure rate. And this is a 2% increase. You want to be on the bottom side of this graph here. You want to decrease your change failure rate. A 2% increase in change failure rate across a 4% benchmark means shipping 50% more defects than you were before. But then same here at the bottom, shipping 50% less, right? So a big takeaway here is that especially as leaders, we got to measure, right? We need to understand where we are. And if we're on the wrong side of this graph, we need to be really strategic in thinking about how we get on the right side of it. Because as everyone knows, right, AI is an accelerant. It accelerates good and it accelerates bad, right? And we are seeing absolutely widespread adoption. One thing that is definitely consistent is that we're seeing now 90% overall adoption of AI across the companies that we sampled. This was a broad sample of 135,000 developers. And we're getting from light utilization on the lower end of the scale to more moderate and then high utilization. So this is basically monthly, weekly, daily is kind of the scale there. All right. So this has all happened very quickly. And we're going to talk about how this is like reported metrics, but that it's probably more like 100%. And I'll show you that in a minute. We're finding that across, again, a broad sample of engineers, that regular AI users are saving about 3.8 hours a week from code completion and that sort of thing. This isn't also talking about integrating agents throughout the SDLC. That's a whole other topic. I do have some data on that as well. But this is really like the code completion thing. So, okay, 3.8 hours a week. I think it's also very important, though, to remember that, the DORA State of Developer Experience report that just came out still reported that engineers on average, because of so many other time sinks and stuff, are lucky to get 5 to 6 hours a week of focused time writing code. So as impressive as this is, it's not necessarily the bottleneck, I think, for most organizations, right? But this is what we're seeing across a broad sample. 22% of code across this sample is now authored by AI, right? And when we looked at the sampling, we were very careful not to just look at telemetry metrics here, right? Because telemetry metrics don't always tell the full story. When we get a little later in this presentation to measurement, I'll talk about sort of the 3 types of metrics that you want to correlate together to get a good picture about impact. But in this case, like for instance, how do we know that if an engineer like accepted the code changes, that they didn't just go and then rewrite every line of it afterwards, right? So that would mean like the code didn't actually make it from AI to production. This is code that made it from AI to production, right? And we have some technology that's coming out soon where we look at various hashes and things like that going on in the file system to be able to automate this. But this is the data that we found right now. Okay. Daily AI users are shipping 60% more PRs. Now, what's in those PRs, right? We know we have companies that are, mandating top-down use of AI. Just like we always sort of tell people not to focus on any single metric, 100% utilization across the company doesn't really say anything, especially if there's a mandate to do it, and especially if that mandate is being weaponized or incentivized. Because there's this little thing called Goodhart's Law. I'm from the South, and we say when you're talking about developer experience, you can't swing a dead cat without coming across Goodhart's Law. Anybody familiar with that law? A couple of you? All right. It basically says that when a measure becomes a target, it ceases to be a good measure, right? And the reason for that is because we're humans, and especially as engineers, we're going to find a way to hit that metric, right? If we're told that we need 100% utilization across the company to use AI, like, okay, we will update our README file every morning, like using Assistant, and we will look like we've got 100% utilization. There's a great parable that goes alongside Goodhart's Law called the Cobra effect. Anybody heard of that one? Okay, so it's a good way to explain it. It's a silly story. You have an emperor who has a problem with venomous cobras in the kingdom, and so sets up an incentivization program. Hey, bring me 100 dead cobras, and I'll give you some money. All right, so I'm incentivizing now the number of dead cobras that you bring me. So some people got clever. What do you think they did? They started farming cobras and killing them and bringing them to the emperor. All right, so we're gaming the system. Emperor gets wind of what's going on. The people are cheating, kills the program, and all those farmers release all those cobras, and the problem gets a lot worse, right? So we do have to be careful about what's in these PRs, but we do know that it's definitely accelerating. So you're seeing it going from daily to weekly to monthly to never. So very satisfying kind of graph there, and then an area that we have no data. I want to point out, because we're going to get back to this, that the metrics showed us that people who are never using AI are using AI to ship 1.3% or 1.3 extra PRs. So we'll get into that in a moment. Okay, so that's just kind of what we've seen in terms of current impact. This is all very fresh data, by the way. We ran these samples back in mid-October. Now, I know that things are moving very quickly, but this isn't like some study we did like a year ago. We'll continue to put out these types of reports at least quarterly. We've built sort of a mechanism to do that, and it's pretty easy for us to glean this data. So keep an eye out on stuff that we continue to push. All right, some interesting trends, though. Junior engineers are actually using AI the most. So we're seeing junior engineers here on the left, mid-level senior, and then staff plus. And then these darker areas are daily active use, right? So we see junior engineers actually making use of this technology. Now, I've been writing code professionally since the late 90s, okay? I was just as reticent. I've been a staff engineer, and I've been through that whole, like, oh, it can't do it better than me, I should write the code, or I like writing code. And, I've come around to the fact that, like, the optimization of developer experience and productivity has always been about reducing toil, right? And in my opinion, it now sort of behooves us to rethink that definition of toil, right? Like if there is something like writing mid-loop code, like I know my function header, I know what my function's supposed to do. Do I really need to write the code in between? What if you like coding? Great, work on an open source project, work on a passion project. But if somebody's paying you to write code efficiently, we have to get to a point where, we can at least trust some of these things that work well, much better than they did like a year ago, over to some of these agents and these assistants. But I think with junior engineers, you don't have that much of a problem, right? Because they're still learning newer skill sets, right? So it's interesting to see these adoption trends. And I imagine that we'll see this change over time. I was definitely one of a skeptic before I kind of became a believer, and I think a lot of people are kind of going through that journey right now. So staff engineers, though, interestingly, save the most time. So even though they're lagging in overall adoption, they're generally going to be better at understanding when code is well written, when it's ready to ship, right? When there's issues with the code. And so they're going to be more efficient in these tools once they start getting better at them. We have definitely realized a trend across the board. This is like almost every company that we sampled, and it didn't matter whether you were a junior engineer or a senior engineer. There's absolutely this sort of J curve that when we move from no adoption to light adoption, and if you're a leader in the audience, you kind of have to be ready for this. During that none to light adoption phase, productivity across the board went down, and so did quality. And then we moved into moderate and heavy adoption. It outpaced where we were before, but it was such a clear indicator of this like experimentation and learning period. Like it's really necessary to allow engineers to get the right type of education material, have time to implement that education, have time to experiment, and just expect that things might get a little bit worse before they do start getting better, right? So I do think it's interesting though that then when we see these heavy users of AI on the staff engineering side, we're outpacing senior and mid-levels with this heavy adoption. So even though staff engineers might be slower to adopt the technology, when they do, they end up saving more time. They end up actually being better with it. So something to think about there too. If you're still having some reticence in the organization, and you don't want to drive the top-down mandate for all those reasons that I just said, but you do want to encourage all of your engineers to be able to take advantage of great new technology and to be able to learn new skill sets that are in all likelihood going to benefit them from the rest of their careers, right? So here's some data to suggest that when us stodgy staff engineers actually do start using this stuff the right way, we actually have better results with it. This is pretty interesting too. We saw that traditional enterprises actually have higher daily AI usage. We saw smaller companies, and I'll show that in a minute, start adopting the technology sort of faster. But I just did a readout on another DORA report, literally in a panel like 3 hours ago, that talked about one of the biggest indicators for like the good use of AI, and some of you I'm sure are starting to come across this, is like clear AI policies and basic change management. And this is something that a lot of enterprises have already sort of perfected. So even though they might be a little slower on the rollout and things like that, by the time they roll it out, there's higher usage. And I think that that's because of enterprises already having a lot of health around change management and around clear AI policies. It's a really good report by DORA that has like it's called a Bayesian posterior distribution graph. And it's like kind of like these hills with a dotted line in the middle. And the graph kind of tells you where you're going to see positive or negative impact across certain things, in this case with the use of AI. And you want to be like on the right side of the dotted line. And you want this sharp kind of peak, because that sharp peak means that we have a lot of confidence in the data in that part of the report. And like mandatory training, clear AI policies, and time to learn and experiment were by far the leading indicators of people having a lot of health in the implementation of this stuff. And I think that, again, that's something that's easier for enterprises to be able to initiate because they already have that kind of stuff. Like they already have these kind of programs that are in place and being used at scale. So it was interesting to see this. When Laura and I first kind of found this data, we were like, nah, that can't be right. But then we really started, I mean, we resampled, and we're like, this is what the data is showing. But then when we really started thinking about it, and we started thinking about these variables, it kind of did become, started to make sense. However, smaller AI companies are using AI more frequently, right? So we see like the heavy adoption with companies that are less than 50 employees or 50 engineers are the ones that are reaching that heavy adoption phase faster, right? So again, I mean, that's also not too surprising, right? Small, scrappy, not a lot of clear AI policies. This may not even necessarily be a good thing. I mean, like the unregulated and unmonitored use of AI at scale can really bite us, can get us on the bottom side of that graph that we showed earlier, okay? So I think there's something interesting to consider there. So again, kind of within that, like that use that we see coming out of enterprises, it was also very interesting that enterprises were leading in actual time savings. So when we actually start looking at the output metrics themselves, and we figure out like, what actually has been the impact, all of these things, like clear policies, like education, like all this stuff means that there's more efficacious use of AI in enterprises. So we're seeing like companies below 50. This is effectively the amount of additional PRs that they're shipping. This is the hours that they're actually saving. And we see enterprises over here on the right with 1,000+ engineers actually saving the most hours per week once they reach that sort of heavy adoption phase. There's some interesting trends here too, where we see these, 500 to 1,000 engineers with light usage actually kind of lagging, right? But yeah, very interesting data here too. But I think, again, more food for thought that like going back to the first principles, the code hygiene, the compliance, the change management, like all these things are incredibly important for getting the most ROI and the best impact out of AI. All right, so back to that graph where we said people that were never using AI were shipping an additional PR a week using AI, right? I think what's going on here, and you're probably seeing this within your own organization, what we were reporting on were like enterprise APIs and telemetry coming out from enterprise APIs, meaning enterprise licenses, right? So if you bought Enterprise Copilot or Cursor or something like that, the only metrics, the only usage that we're really able to get from a systems perspective is the telemetry coming out of those APIs. But remember I said before that DX captures qualitative and quantitative metrics. So what this was saying that even though the licenses didn't show that there was utilization of AI, we still had qualitative signals coming from people who were not using AI, quote unquote, talking about significant time savings in what they're doing. So this is like 11% merged code that was qualitatively reported as being written by AI by people who, according to the API, had never used AI, right? So these are personal licenses for Cursor or people pumping stuff into ChatGPT. But this is something that really, like, we're going to have to get a handle on this, right? I mean, I am by no means a proponent of a single solution. I think we need to be using multiple solutions, especially in enterprises right now, where some of these procurement cycles can take, 9 months to a year to actually roll something out. And by the time you do, like 3 other technologies have leapfrogged it. I mean, things are just moving too quickly for that right now. But we are going to have to kind of unify if we really want to understand utilization. When we get into measurement in a moment, I'll talk about why that's important. The best way to measure this stuff is to correlate utilization, daily active weekly use amongst cohorts to our core and foundational productivity metrics that we've been able to trust for a long time, right? So our DORA, our SPACE, our DevX, our core 4 metrics, right? We want to see how utilization in these cohorts impacts those other metrics. But we'll get into that in a little bit. I just think it's very interesting to kind of see this data play out. This is one of those areas where, although system metrics are certainly important, we need context coming from qualitative metrics to really understand like the full picture. We like to use a lot of health metaphors at DX, so it's kind of akin to like you go to the doctor and you don't feel well, and you tell them, I don't feel well, and then they take your pulse and your blood pressure, and they're like, well, you're fine, all your metrics are, yeah, but I don't feel well, right? Like the context is very important there. And this is one of those areas where we're able to kind of pinpoint pretty clear shadow AI usage as a result of marrying telemetry and API metrics with qualitative and self-reported metrics. And let me be clear too, we're talking about surveys with 90% plus participation rates. These are like strong signals. No big surprise here. AI is delivering bigger gains in modern languages, right? So we see like Golang, Python, Rust, JavaScript here on the left. On the right, we see poor old COBOL. I was actually just talking to a new friend of mine from Atlassian. DX was acquired by Atlassian back on the 10th of this month. And they needed, somebody had asked them to effectively figure out whether, in this case, RoboDev, would be capable of an end-to-end conversion of COBOL code to Java code. So he needed a demo for this. Turns out there's a Minecraft server coded in COBOL, an open source one. And so we use that to start doing it. And, it's much better at interpreting. Morgan Stanley has been very public about their creation of an AI agent called DevGen AI. And what DevGen AI does is reverse engineering of legacy code. So you can imagine Morgan Stanley has a bunch of legacy code laying around. They got mainframe natural. They have COBOL. I hate to admit it because I used to write a lot of Perl, but Perl considered legacy now. Rather than a full end-to-end translation solution, though, because it's difficult to get the full context and everything like that from COBOL, they're just creating developer specs from all this legacy code, right? So the bots seem to be better at least interpreting COBOL than necessarily transcribing it, right? But yeah, this is across 23,500 developers over 48 companies. And we again see that as the languages get a little bit older, the AI is just not as good. And that's because of the stuff that it was trained on. Also, some of it is like thinking about the domain specificity of some of these languages. Like for instance, JavaScript. Like of course, React and TypeScript works pretty well with these assistants because it's just code that's running in the browser, right? Even if you're writing like crazy JavaScript that's somewhat domain specific, the semantics of the code itself are still bounded and standardized by the DOM and the browser itself, right? So the AI doesn't, it's much different than trying to interpret or understand a bunch of backend code that might have a lot of domain-specific semantics and things like that. But yeah, pretty satisfying graph here too, but I wouldn't say terribly surprising. This one's big. There's a significant impact on just overall onboarding, right? So what this is across 14,000 developers, the number of days that it took to onboard a new resource, either into an organization or a project. And I mean, look at this ramp down. Coming from back in Q1 of 2024, before AI had sort of begun to proliferate, we're looking at this 78-day ramp time. And we have more than cut that in half now on average. Zapier is, in my opinion, doing really, really well with AI agents, which shouldn't surprise anybody. They're like an automation-first company. But I got a chance to speak to one of the folks who works on building agents and AI for Zapier. And they've done all kinds of stuff. They love to joke that they've got more bots than humans at Zapier and everything like that. They have a really nice grassroots program for building agents. And one of the things that they've been able to do is move their onboarding time from 30 days down to 2 weeks, right? So effective time from an engineer now coming in less than half of what it was before. They're also able to get about 15% more productivity out of every engineer. So they're doing what I think everybody should be doing. They're hiring more, right? They know that they can make these resources more valuable faster, and then they know that they can get more return on investment out of a single hire. So they're hiring faster than they ever have, right? Now, I mean, I talk a lot. I have other workshops where I talk about the importance of psychological safety and the adoption of AI. And one big bit of psychological safety is making sure that as leaders, we are very clear, we are augmenting with this technology, right? This technology is not ready to replace. And I can cite multiple examples of companies that have been very public about saying, we're going to fire half our engineers, and then we're going to replace them with agents. And it doesn't work. And then they have to rehire those folks. But no one wants to work for them because they ruin their reputation by firing everybody, right? We have to really remember now that this is about augmentation. But this is a perfect example of how we can really get more value, how we can make a resource by using agents and using various forms of AI more valuable to the company more quickly. And I think Zapier is an excellent example of that. I'll have a newsletter article coming out about that interview pretty soon. But I really do think that it was very inspirational and even refreshing for me to kind of talk to that person and hear that coming from Zapier. Okay, we're also having to redefine the notion of a builder in the organization, right? So traditional non-builders now are shipping much more code. We're seeing engineering managers actually shipping twice as much code as they were as a result of AI. This is also being reflected, as I'll look at in a moment, like project managers and stuff. But we have to start rethinking who's a developer, right? When you have project managers that are able to crank out decent prototypes, when you have engineering managers that can now take on a player coach role, but not in a bad way where they're overwhelmed, where they're actually getting a chance to contribute to code bases along with managing teams, that's a fundamentally different world. And I think makes for a better manager, right? I mean, somebody who's going to be able to kind of understand, the weeds of what's going on and actually being able to contribute, I think is going to have better empathy and better managerial capabilities for their engineers. Same with designers and PMs. We're seeing 7.4% daily active use for designers and project managers. And I don't think that's too surprising. I mean, Figma has one of the most powerful MCP servers out there. It's really, really good. And you can have project managers now. Canva's been really public about having their project managers. They've built a small agent that allows project managers to natural language what they want the product to do. And then it goes into MCP via Figma, and it creates a prototype, and it creates nice developer-friendly specifications. So not only is it easier for the PMs to put the PRDs together, but that translation layer of like, what is this project requirement supposed to do, and the developer actually being able to understand that in their own vernacular is another friction point that's been fixed by that agent, right? So yeah, we have to really start rethinking who's a developer in the organization anymore when we're actually able to elevate traditional non-builders and have them make contributions like this. All right, so that's a lot of good news. But here is a very important point that I think we all need to remember, is that there are still so many pain points for engineers that have nothing to do with the generation of code that are absolutely eclipsing the time savings that we're seeing coming from AI. So when we annualize this, that pale bar there in the middle is overall annualized time savings across, this was a sample of 134,000 developers. 134,000 developers. That AI time savings, it's not insignificant, but it is absolutely eclipsed by interruption frequency, so context switching throughout the day from various sources, and meeting heavy days, right? We all know that, right? What a developer's always, I have too many meetings, right? There's some stuff that we can do around this that AI can help with. Like going back to Zapier, they've reduced their daily stand-ups from 5 days a week to 2 days a week because they're doing like summary of meetings and change logs and things like that and using asynchronous updates instead of running stand-ups. But there's also some old school business stuff that we can apply here too. Like I'm a huge Ellie Goldratt theory of constraints fan, and one of the thinking models in the theory of constraints is something called the evaporating cloud. And if you've not heard about that before, it's definitely worth looking into. It's a way of reducing assumed dependencies within an organization, which can have the net effect of reducing the number of meetings in that organization. So there's non-AI stuff and AI stuff that we can do to deal with some of this. Interruption frequency and context switching, like I can't emphasize enough how detrimental this is to organizational productivity. There have been a number of studies. One of them is called The Coding War Games. Anybody ever read the book PeopleSoft? Tom DeMarco, Timothy Lister. Great book. Totally still this is one that I keep at my desk, not even on my bookshelf. Right? I reference it a fair amount. It was a series of studies that started in the late 70s. And engineers took part across about 100 organizations in the first study. And there were about 700 engineers that took place in this first study. So you had engineers within a single organization competing in this study. And then you also had full organizations competing against each other. Now, they found some really striking stuff. First off was that across organizations, there was an 11x difference in productivity. You had some organizations that were 11 times as productive as the lowest performing organizations in this study. Within a single organization, there was only a 20% difference between top performers and lower performers. Now, anybody familiar with systems thinking or profound knowledge or the work of W. Edwards Deming, this should not surprise you. 90 to 95% of the productivity output of an organization is predicted by the system and not the worker, right? So what we see here is that even the most amazing developers are constrained by the systems and process and culture in which they're working. Some of the non-factors in this study were things like language. People hypothesized, oh, well, so they must be using some really high performance. No, the only lower performers really in that study that were significant were assembly developers. They thought that maybe salary would be impacting this. Only a 10% difference in salary between the highest performers and the lowest performers in this study. What they did find was when they answered questions like, do people often interrupt you needlessly? The top performing organizations in that study overwhelmingly had people say no. So the things like divert your phone calls. This is back in the day we had chunky conference phones and stuff but can you divert? The same thing as Slack, Teams, anything now. Like 5 times as many people in the top performing organizations answered positively that they could divert their calls, right? So this all came down to like encouraging flow state, minimizing context switching. Like these were the biggest indicators. And I think we're still seeing this here, right? Where it's like, yeah, we're getting some good time savings from AI, but our time sinks are still eclipsing that. And there's stuff that we have to do with our system and our process and our culture to fix that. There's a well-defined neuroscience in place here too, and this is part of why I love focusing on developer experience. I spent the last 7 years of my career or so just singularly focused on developer experience study and productivity. And it's this wonderful sort of confluence of engineering and psychology and cognitive science and neuroscience. And there's a lot of really good details out there. There's a great Scientific American article that came out just a few months ago that studied flow state in improv jazz guitarists. they can go into flow state almost immediately. And so, of course, we did what we did. We put brain caps on them while they were playing guitar, try to figure out what was happening with them. And it was fascinating. Like, we've all experienced flow, and we know how productive we are in that state. We know that that's the highest innovative capability and most creative time when we're experiencing flow, and it feels good, and it's satisfying work. And what's happening is long-term knowledge from the back of the brain is getting shuffled into the prefrontal cortex, and it's going back and forth and taking over some of the executive functioning, which is where that timelessness sort of comes from that we feel when we're in that state. And we're throwing off norepinephrine and dopamine and serotonin and all the great feel-good neurotransmitters when we're doing that. So the brain, quite intentionally, separates work throughout the day into these sort of chemical chapters of flow and then context switch. So something interesting happens in the prefrontal cortex when we get out of flow or are pulled out of flow. The brain releases the glutamate neurotoxin into the prefrontal cortex and says, okay, we're done with this chapter of work. Here's some glutamate. Then we reach a point where we reach a threshold where we experience cognitive fatigue, right? We have too much glutamate going on in the prefrontal cortex, and so it's time to stop working and get some rest. Or if we're going to keep working, it's not going to be our best work, right? That's the funny thing about cognitive fatigue. Especially in Western culture, like, we're very productivity focused, and so even when we're tired, we sometimes still have to do work. But the thing is that it's really hard to elevate that work. It's really hard to innovate. It's really hard to be our most creative selves when we're in that state of cognitive fatigue. So a lot of the study of developer experience is really focusing on how do we extend these flow state chapters as long as we can to minimize context switching throughout the day, to minimize the overall amount of cognitive fatigue. And it's kind of weird to think about, but there's absolutely a relationship between, a software-driven culture like ours and the capacity for global innovation and the amount of context switching that our engineers are having to deal with, right? So I spend a lot of time on this because I think it's really, really important. Like, we often kind of blow off this notion of like, oh, well, I just get slacks all day, or I'm in too many meetings, and it's like, this is a big problem. And it's not something that we can fully solve with AI. So AI is great for a lot of things, not a silver bullet. And there's some other things here too, like build and test time, right? I used to work for Gradle. It was my first real foray into developer productivity engineering. We focused a lot on inner loop optimization, like reducing build times, reducing test cycle times, failure rates, and stuff like that. Still, I mean, like, you start combining some of these things, like developer environment toil, review wait time, build and test cycle time, you start compounding these, and they also eclipse the savings that we're getting from AI. Okay, what about some things that really do save us some time? So here's another study that we did. You're welcome to download. This was a study that we put together where we started capturing AI and ROI metrics a while ago in our platform, and we wanted to just help. We wanted to create a resource that could help our customers see better ROI. And of course, we found overwhelmingly that education and enablement had a lot to do with, like, making this technology work really well. So we did a study where we came across engineers who were reporting at least an hour a week of time savings when we did this, and we surveyed them. And it was a very simple survey. It was just like, please stack rank what you think your top 5 most valuable use cases are for AI. And we did similar stuff with S-levels who had already rolled out AI, like, successfully to thousands of engineers. And we asked them to talk about what best practices they were encouraging and what they're trying to encourage their engineers to kind of teach each other to do. And where we found commonality, we included those best practices in this study. And then we turned that, stack rank your top 5 into this sort of top 10 list of time-saving use cases. I think it's really interesting that stack trace analysis was number 1. I mean, now, of course, put anything in agent mode and it's already kind of do this for you. This is another one of those, like, philosophical points, though, where it's like, when I was still a developer, but when I was writing code professionally, like in the late 90s, early 2000s, there was a lot of Java and became more JEE stuff. And then some Spring and things like that, which we all know spit out terribly long stack traces that we're then sort of like going line by line through to try to figure out what's going on. But it can be a bit of a puzzle. Like, I mean, as an engineer, sometimes you like to solve that stuff. But this is another one where it's like, no, you got to give this over to the AI. It does a great job with stack trace analysis. But I think it's interesting that it's an interpretive use case and not a generative use case. We saw some other things here, like refactoring existing code. Yeah, absolutely. Mid-loop generation. In other words, I'm going to write the function header, and then maybe do a comment about what this function is supposed to do. And I'm going to let you just fill in the middle for me, right? Because I'm still using my higher order thinking, understanding what this function is supposed to do. I don't really need to write the code in the middle. Test case generation, no-brainer, right? Learning new techniques. Another philosophical point that I get when I give a workshop that's kind of designed around this guide, people ask me, well, Justin, are Are we actually learning? And I think it's like a really good question, right? I mean, for one, I mean, like I was always directionally challenged, but I can't get anywhere with my GPS. It's like impossible. Even my hometown and everything, I get lost because I'm, just blindly following what the GPS is telling me to do. Is that what's happening with code generation? The answer is maybe, and it's up to you, right? Like this is your personal responsibility. This isn't any different than like when we used to copy paste code from Stack Overflow, right? Like it's up to you at that point, like, do I want to understand what this code is actually doing? Do I want to learn and become a better developer? Or am I just in a rush and I have to hit the easy button? So you absolutely can learn new stuff if you so choose, right? And so, letting the agent just do stuff and then just sort of trusting it, no, you probably won't be learning. But taking that extra moment to see what's happening and try to understand what's happening, not only will you generate better code in the long run, but you'll become a better developer. Complex query writing. So when I give this workshop and I happen to be home on Zoom or something like that, I point over to my bookshelf where my Mastering Regular Expressions book lives and has not been cracked in ages, right? I don't write regular expressions every day. So getting the agent to do something that you don't do every day, like a regex, or feeding it some context about your schema and having it generate SQL queries, another really good use case. Certainly code documentation in multiple forms, right? So I'm one of those weird engineers who actually does like writing longer form documentation when I write code, but I hate commenting. I know how important it is, right, for posterity and everything, but I just want to kind of flow my way through and then not have to worry about writing comments. These things are great at inserting comments, right? So we tend to think in terms of it like generating markup and things like that, which is a very valid use case, but auto-commenting the code is really good too. Yeah, brainstorming and planning, one of my favorite recursive workflows. This is now a first-class citizen in like Cursor Plan. Amazon Kiro was one of the first to bring this to market. I think it was the first to bring it to market as a first-class citizen inside the IDE. This is basically where you just say, okay, I'm a computer programmer and you're a project manager. Ask me one question at a time about this thing that I want to do, and then create a specification based on our conversation that I can then use to maybe scaffold code or whatever. This is one of those ones, even as reticent as I was at first, that has completely changed the way that I work, right? I mean, back in the day when I was writing code, you always miss something in that early planning phase, and then you sit down to code, and it bites you later, right? This is a really great way to get that comprehensive plan kind of out first. I think about it as kind of like rubber ducking 2.0, because it's like I'm discussing what I want to do, but I'm actually getting feedback, and then that feedback is turned into a plan. So I was very, very pleased to see that come out in Amazon Kiro when I started using the public preview for it. Now, of course, it's made its way feature parity into other tools. But yeah, I totally like this one too. And then code explanation, initial code scaffolding. So yeah, the guide itself is about 65 pages long. It gets into more than just these top 10. It gets into prompting techniques like meta prompting and recursive prompt chaining and things like that. And so you can use this as a reference if it's helpful for your engineers. We've definitely had some organizations that they're calling it like required reading now for their engineers. But it's a good way also to get more ROI out of these tools. Okay, speaking of ROI, how should we be measuring all this stuff? Well, measuring productivity and even defining productivity was already difficult. And the engineering landscape, the industry had not already sort of landed on and aligned against and commoditized the best way to do it. And then AI came out. And now we're trying to solve for measuring ROI and productivity because we have people we have people on the board and we have CTOs and stuff asking for, what's the ROI that we're getting on all these massive AI investments that we're making. And the unfortunate truth is that a lot of us weren't even good at measuring this before AI, and now we have a whole new factor that's come in. But what I hope that does is actually accelerate our paying attention to this different ways to measure. So even what we do at DX is not perfect, but I think it's the best model, right? Again, we've kind of combined Dora metrics with Space Framework with a metric framework called DevX, which focuses on cognitive load, it focuses on context switching, feedback loops. So if you're doing the core four, you're doing all three of those metric sets at once. And then it was kind of on us to say, well, look, all of our customers now want to understand the impact that AI is having on our productivity. And so we studied with a couple of companies for a couple of months, and then in sort of a fever dream state over a long weekend, myself and Abhi, our CEO co-founder, and our other CTO, Laura, just banged this thing out, right? But based on data that we'd pulled from the system and based on interviews and things with other companies, I'll show you a few of them in a moment. So we found out a few things, like as we were kind of putting this framework together. We kind of thought about 3 different types of metrics and kind of their strengths and kind of their challenges, right? So the first, of course, is our telemetry metrics, right? This is getting stuff from Copilot API or Cursor API. Anthropic and Claude didn't have an API, but we had customers who wanted to get that data, so we worked directly with Anthropic to build their API for Claude, which is now, in my opinion, like a really good API. But there's not always like a full story that's going to come out of this, right? What does utilization really mean, right? What does daily active use, weekly active use, monthly active use really mean? Forget accept versus suggested lines of code. Lines of code was never a good metric to begin with. I don't know why we think it would be good now. Especially when we look at the fact that the only way that the API knows if the code has been accepted is if a button was clicked in the IDE, and there's still no way to tell after the fact that the engineer didn't just go and rewrite every line of code that was generated, right? But it's okay for like understanding like what's happening. You know, it's okay for saying like who is kind of using this stuff and who seems to be like using it more than others. But it's not until we start getting into what we call our impact metrics, right? How does this cohort, some of the trends that I've already shown you, like how does a cohort or usage correlate to PR throughput or PR merge rates or code confidence, change confidence, or change failure rate? So speed and quality metrics, right? Now we can actually start correlating this stuff, right? And so it's useful for that. Experience sampling can be great for collecting small bits of data and starting to quantify some ROI. So this is, for instance, like interrupting a developer as they're already in a workflow, but hopefully not in a way that causes a context switch. So like, for instance, a great example, good textbook example is adding one additional field to a PR form where they're already having to fill out a PR that says, I used AI to work on this PR, or I enjoyed using AI to work on this PR, right? We get that one little piece of data. It can be a little difficult to set up though, and we have to run this over a period of time, right? We want to get longitudinal data from this to kind of understand that impact. Then finally, self-reported data, surveys. Again, we're a little biased. We've done a great job of engineering our surveys, and we get great participation rates in our surveys. But when you do this, these signals can be incredibly strong. I was just talking to someone at Slack who gave a talk at the same little event that I was doing a few hours ago here in the Win. And Slack relies mostly on the qualitative signals that they get because they get like 92, 93% participation rates in their engineering surveys. When you get that high and when it's a well-engineered survey, we even say like trust the qualitative metrics over the system metrics. Like you need both to understand what's fully happening. But if there's like a deviation where it's like the system metrics seem to be telling you something that's different than the qualitative metrics, when you have that good, strong signal, we're like, yeah, trust the qualitative metrics and figure out what's wrong with the system metrics, right? So that's where this self-reported data comes in. But we all know, you know, they can only be run periodically. We really don't want survey fatigue. You know, we feel like quarterly is about right. The real number is how long it takes for improvements to flow through your organization, and that's going to change based on your culture. Because the last thing you want to do is keep running these surveys that just never change, right? What you want to be able to do to get engineers excited about taking surveys and providing feedback is showing that the audience is looking at these signals and saying, okay, great, thank you for this feedback. Here's what we're going to prioritize improving over the next 3 months, 6 months, whatever that is. Then we're going to benchmark again and say, okay, well, did this actually move the needle? Then you have engineers that figure out, okay, well, actually, this feedback is kind of making my life better, and I kind of like it. So that's how we end up in these nice flywheels of continuous improvement. So yeah, telemetry metrics, experience sampling, and self-reported data, and we really recommend that you do all 3, right? Because each of them are going to do different things and give you a full picture. This is the measurement framework itself. So again, this was the result of working with a number of companies, as well as what we already knew about productivity. You can use this measurement framework in a few different ways. In one way, it's just like looking at the raw metrics, understanding what metrics are important. None of this was done in a vacuum. These all represent metrics that across close to 40 different companies that we ended up looking at what they were paying attention to. We found commonality and we put them in the framework. But it's also inspired by the SPACE framework in that it's not just metrics, it's dimensions, and more importantly, oppositional dimensions, right? One great way to think about good metrics, and this is not me, this is the author of the SPACE framework, Margaret Ann Story, Peggy Story's good friend, is to look at a constellation of metrics in tension with one another, right? And so that's why we always map these metrics into these oppositional dimensions: utilization, impact, and cost. You can also think about this as a maturity curve, right? Most organizations are starting on the left. They're getting utilization like daily active use, weekly active use, the percentage of PRs that are AI assisted. And then as we start gathering those, what's going on metrics, we move into the impact metrics. And some of these should look familiar if you're already doing like DORA or if you're familiar with the core 4. So these are things like developer satisfaction, PR throughput, perceived rate of delivery, change confidence, change failure percentage. So we want to start again being able to correlate this. And then, of course, cost. I mean, I do like to point out that we're 15 years past the last major hype cycle, and we're still figuring out how to control our cloud costs in a lot of cases. That's why a lot of us are here. But I'm also hearing horror stories about engineers burning through like $3,000 worth of tokens a day. So we are going to have to get a handle on this. But what we're finding is that then in that maturity curve, it tends to be like the utilization metrics first, followed by the impact metrics, and then these cost metrics. Okay, so that's the framework. Lots of ways to gather this data. Just like Space Framework, we don't really prescribe how to gather the data, more that you normalize the data into these dimensions. So these are just a couple of the companies that we worked with to put this framework together, and some of the metrics that were important to them. So Microsoft, looking at adoption, just like Dropbox, just like Booking, so some commonality there for adoption metrics. Microsoft looking at things like system velocity, developer satisfaction, change failure rate, and one of my favorite metrics of all time. We don't have time to go into this right now, but it's called a bad developer day. Microsoft has a great white paper on this if you look up the Microsoft bad developer days. And it's basically like gathering telemetry from a whole bunch of different areas of the workflow and putting together signals that said, yeah, this developer had a bad day, like too many meetings or too many incidents. There's a lot of different metrics in there. But then they're correlating this to AI utilization. And look that one up, it really is kind of cool. Dropbox, who has been hyper-focused on developer experience since the beginning. Their CEO opens up the DX platform every morning to look at how developer productivity metrics and experience metrics are going. They're looking at adoption. They're looking at developer sentiment velocity as well, percentage of AI code lines that were added versus the total lines added. Quality, they look at change failure percentage. Change failure rate's a great metric, tells us so many different stories about what's happening with quality in the organization. And then Booking.com, yeah, daily active use, weekly active use, overall time saved, PR throughput. So you see some commonality here, and where you see this overlap, this is how we put this metric framework together. So this is pretty well trusted. Like these metrics have now been validated, not just in our platform across millions of developers and data points and things like this, but across other companies too. So there's no way you can read that. That's another set. Maybe you zoom in on your phone or better look at it later. It's also in that guide that I mentioned before. But these are just what some other companies are looking at as well. So GitHub, Toast, Grammarly. But again, I really want to stress here that AI metrics, again, measure what's happening, but core metrics measure whether these investments are working, right? And those haven't really changed, right? I mean, we still are looking at speed, velocity, but also quality. But I think it's important that we understand that hyper-focusing on any metric, like we said before with Cobra effect and Goodhart's law, is bad. But only looking at utilization metrics are not going to tell you the full picture. They're not going to tell you whether the investments are actually working. That's what the core foundation metrics are for. All right, so in summary, we do want to, as I mentioned before, avoid vendor lock-in. Like, these tools are leapfrogging each other. We want to expand the definition of a developer. We want to measure AI adoption. Hopefully, this framework was interesting, or at least some good food for thought about what you can be measuring. But also remember that AI is not a silver bullet, right? That even though we're seeing these time savings in some places, those time savings are often being eclipsed by other sources of friction, toil, context switching, and things like that from developers. So final resource I'll share with you. A lot of this is summarized. The measurement aspect is summarized in this strategy playbook for senior executives. We get into a lot of stuff in this guide. We get into how to think about integrating across the SDLC. I mentioned I love Ellie Goldratt, means I also love value stream mapping. So there's a lot of information in here and how you can use your value stream maps to determine where agentic AI is really going to help you. I dive a lot into psychological safety. I talk about Google's Project Aristotle where they ran this study where they had this hypothesis that the most performant, like highly performing teams were going to be a result of like really good management and really great developers and unlimited compute resources, and they were totally wrong. And what they actually found out was that psychological safety was overwhelmingly the most important factor in a high performing team. And I think that's more important now than ever with AI. We'll get into things like compliance, trust, security, and we'll get into how we can sort of tie these skill sets to employee success, right? And really try to remind employees that you're giving them an opportunity to learn about something that, again, will likely benefit them for the rest of their career. And that's all I have for you today. Thank you very much.